Hey, I'm gonna take 2016, 2015, and 2014 Regents Physics exam. I'm gonna take the short response one. So here I have 2016, and here I have 2015, and here I have 2014. So let's get started with 2016. What I need to have to take the reasons, I need to have a reliable calculator, a protractor, and a reference table. And so let's get started from 51 to 85. That is this short response. So let's go to the 51. So 51 right here. So 51 is a problem that there is a box sitting on a table, and there is a loss of friction on the table, and there is some applied force that is 15 Newton. And when there is a applied force, then there has to be some acceleration, and acceleration is 2 meter per second square. And we need to find few things. Calculate the magnitude of net force. We need to find the net force. So let's first find the net force over here. F net is equal to ma. That Newton's second law. So m is 2.5, so 2.5 kilogram, and a is given 2 meter per second square. So that is F net. So F net is equal to 2 times 2.5, that is 5 kilogram meter per second square, which is Newton. So we are done with 52 and 51. Now let's see 53. Determine the magnitude of the force of friction. Now we have to find the force of friction, this force of friction. Now please understand that net force is equal to applied force. See, this is the applied force minus force of friction. So that's how we're gonna find the force of friction. So we're gonna write 52 here. Net force is equal to applied force minus force of friction. So we are trying to find the force of friction. So we bring that to the left side, and we send this one to the right side. So force of friction is equal to applied force minus net force. So force of friction is applied force is 15 Newton. So 15 Newton, and minus net force, and net force is, we just found it, net force is 5 Newton. 5 Newton. So force of friction is 10 Newton. So we're done. We're done with this problem. Now we move to the next one. Next one is Snails Law. So we turn to the next page, and that is 54 to 55. So 54 to 55 has to do with the Snails Law, and the Snails Law is talking about, say there is a mineral submerged into the water. Say this is a water, this is a river, and there is some type of mineral submerged into the river, and a ray of light coming out from there. So let's say this is medium, this is medium 1, and this is medium 2. Medium 1 is mineral, and medium 2 is water. And then this is a normal line. We call it normal. So normal line. Now say a ray of light which is 27 degree. Make sure you understand this is 27 degree. We do not count this is 63 degree. That gives you to confuse you. To why this is 26, we're gonna count only 26 and 41. 26 is because 27 is because which is with respect to the normal line, and 41 which is also respect to the normal line. So this is garbage, 27 and 41. So now a ray of light is changing the, so this is a refraction. So refraction. What is a refraction? Refraction refraction is when the light changes the medium, it bends. So that is the refraction. And how do we understand refraction? By using Snails law. By using Snails law. So now this is given 27 degree. So it's hit that medium. So this is the mineral and this is the water. As soon as it changes the water, light bend, and it is now 41 degree. Instead of 27 degree, now it is 41 degree. So this is now 41 degree. What do we need to find? Calculate the index of refraction. So calculate the index of refraction, which is, we can find it by Snails law. So n1 sine theta 1 is equal to n2 sine theta 2. So n mineral sine theta mineral is equal to n water sine theta water. So we need to find the index for mineral. So n mineral is equal to n water sine theta water over sine theta mineral. So n mineral is sine theta water. Here, if you go to over here, then the index for the water is 1.33. 1.33. So you write 1.33 times sine theta for water. Sine theta for water is sine 41 degree. 41 degree. And then sine theta for mineral is sine 27 degree. So Nm is 1.33 sine 41. So sine 41. So write sine 41 gives you 65. So 0.60 say 66. And sine 27 sine 27 gives you 0.45. 0.45. So if you do the math, then the index for a mineral is 1.99, and there is no SI unit for the index. So this is the answer. Now we are done with the Snails law. Now the next part is what number is this? 58. So 58 is 54, 55, 56, 57. Okay, 56, 57. So we're gonna do 56, 57. A ball rolled twice across the same. Okay, now let's say we have a two table. So this is table number 1 and table number 2. Table number 1, table number 2. I have a different color because I used up lots of space over here. Now table number 1, there is a ball here, and the ball has the initial velocity, and the ball has the initial velocity, and this is 2.5 meter per second. So write initial velocity 2.5 meter per second. And so if the ball has the initial velocity, ball has to move. Ball moves, and ball comes here. And when balls drop, it hit the ground. So all we need to find, calculate height of the table. So we need to find the height of the table. So another problem is this one is the same problem, same ball over here, but this ball moves 5 meter per second. 5 meter per second, and the scenario is same, and the ball fall and hit the ground, and how long it takes. Now let's find this one. Few things we need to understand. That the velocity has two components. So Vx initial is 2.5. What is the Vy initial? Vy initial is 0. What is Ax initial? Understand that acceleration at the x direction is always 0. So it's 0. Ay initial is 9.8. Okay, with that information I think we are good to go. So we have to find the distance d. So distance d is a v initial yt plus half ay t squared. So v initial yt is 0, because when it falls it has a velocity at x direction but not at y direction, so it's 0. So d is half 9.8 t squared. So if you solve for t, then you get 0.750 meter. So 0.750 meter. Now the second question is how long how long does it take for this ball to hit the ground? Same time. Same time, because for this ball the v initial y is 0 and ay is 9.8 meter per second square. Same time, because vy initial is 0 and ay is 9.8 meter per second square. So keep that in mind when you take the reasons on June 15. Now that takes us to the next problem. So this one is 7.50 and this one is same. Okay, that takes us to problem number 58. And what is 58? 58 is same. Okay, so this is same. So we answer this question. This is same time. 58 is same time. So same time. Very good. We done with this. This one now that takes us to 59 and 60. So there is an there is an airplane moving clockwise. Clockwise means this way. Clockwise means this way. Moving the circle, which is radius is 8 meters. Everything you see over here, the magnitude of the acceleration is, so acceleration is 25 meter per second square. The diagram shows everything. Now all we need to calculate the speed of the, so we need to find centripetal acceleration. Centripetal acceleration is easy. You know what is centripetal acceleration. You look at the reference table. AC is equal to v square r. So AC is equal to v square r. Now you try to find the velocity. So velocity square is centripetal acceleration times r. So v is centripetal acceleration times r. So v acceleration is 25. So 25 meter per second square, and r is 8 meter. R is 8 meter. So which is 25 times 8. 25 times 8 gives you 200. So it gives you just 25 times 8. So v square over r. R is 8. 25 times 8 is, so is velocity. So acceleration times r. So r is 8. So 25 times 8. 25 times 8, which is 200, and square root of 200. Let's see, square root of 200 is what? Square root of 200 is second, and this guy 200, and that gives us square root. So square root 200, that gives us 14. So 200. So that gives us velocity is 14 meter per second. So our velocity is 14 meter per second. We're done. So the next question is 61. State the direction of the velocity of the airplane. Direction of the velocity is this way, is because the acceleration is this way. So the relationship is the velocity vector and the acceleration vector is always perpendicular. So now 61, we're gonna write this way, because this is the velocity vector. This is the velocity vector, and this is the east. EAST, east. That's it. Now that takes us to the 62. Easy and simple. 62. 62 is, there is a graph. We call it a speed versus time graph. What is the quantity represented by the slope of the graph? So speed versus time graph, that represents the acceleration. So acceleration is delta v over delta t. So this is our y component, delta v. This is our x component, delta t. So this is must be acceleration. So this is 62. We're going to write the acceleration. Now 63 and 4, calculate the distance. So now you can calculate many way. We're going to calculate the easy way. Is ask you to find the distance from 0 to 3 seconds. So 0 to 3 seconds, you highlight that. For velocity versus time graph, this is called area under the curve, which is distance. So this look like a triangle for me. So triangle, what is the equation for triangle? So area under the curve of triangle is half VH. So half B is 3 and H is 4. So half 12, 2 goes to 12 6 times. So it's 6. So 6 what? if this represent distance, so 6 meter. Easy and simple. And that takes us to 65. 65, this is weight and mass. If this is weight and mass, then what is determine the acceleration due to gravity on the surface of the x. So we have to find the acceleration due to gravity. So how can we find it? So this is Newton's second law, because Newton's second law is F equal ma. This is our F, this is our m, and this is our a. So acceleration is easy and simple. Acceleration is, as we wrote over here, delta v. We are trying to find the acceleration. Yes, of course. Acceleration is, we are trying to find the acceleration. So acceleration is weight. So F final minus F initial over mass final over mass initial. Remember, we are using m is equal to delta y over delta x. Okay, so F final, let's find 2 point. Okay, I like this one. So from 0 to 2. So then mass final is 2. Mass initial is 0. This is 6 and this is 0. So 6 over 2, 3, so 3 meter per second square. So acceleration of this graph is 3 meter per second square. Easy and simple. And that takes us to the 65. We're gonna write it down, this number, we're gonna write it down, 3 meter per second square. We're gonna go to the next one. Next one is, we have to use the protector. Look like we say there is something going on with the protector. So I have it ready, why not? So we have to find a hiker, blah 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 blah. So what are you gonna do? You take the protector, you find the 0. So once you find that this is it starts from 0 centimeter, this is 10 centimeter. Always protector, this is the protector. You can use it as ruler, you can use it as a protector. Find the 0, this is 0, this is 10 centimeter. Put it over here, and then you see 5 centimeter. Your goal is to find 1 centimeter is how many kilometer. How many kilometer? Now you just discovered that 2 kilometer is, you just discovered that 2 kilometer is 5 centimeter. 5 centimeter. But that's not your goal. Your goal is to find 1 centimeter is how many kilometer. Divide both sides by in a number that leaves you with 1 centimeter. So divide both sides by 5. If you divide both sides 5, then 1 centimeter is 0.4 kilometer. So then 1 centimeter is 0.4 kilometer. You can put a 0 over here to make it look good, but you don't have to. That's it. Okay. Now you're gonna do 67. 67 is just connecting. 67 connect this one and connect this one. So that's the easiest thing in the wall. In the wall resultant. So you can do many ways. You can do this is the resultant. So resultant is equal to, this is, let's say this is x squared. This is y squared. So resultant is 2 squared plus 1.4 squared. So 2 squared is 4, and plus 1.4 squared is, of course, 1.4 times 1.4. That gives you 1.96. So plus 4, which gives you 5.96. And then if you do square root 5.96, you get 2.44. So 2.44. However, you're gonna do it by the protector. So find the 0. So put the 0 over there. Put the 0 right here. Right here. Once you put the 0, and you're gonna see a number that is 6. That is 6. So you're gonna write that is 68. Okay. Now booklet, a ruler, construct the vector represent hiker of the displacement. You did that. Determine the magnitude of the hiker. So you're gonna write that. You're gonna find the 6 centimeter. So you're gonna write 6 centimeter times you found 4.4 kilometer. 0.4. So 6 times 4.4. 6 times 0.4 is 2.4. Easy and simple. So either you use this or you use this, you get the same answer. So you write the answer 2.44 kilometer. Very good. Now use the protector to determine the angle. So once again, you take the protractor and you determine the angle between east and high curve resultant. So where is the east? This is the east and the high curve resultant. So we have to find this one. So now easy and simple. I'm gonna find the 0. So this is here. So I put it here, and I see this is between. Look, this is between. Look, everyone. Look, this is between 40 to 30. Between 40 to 30. This must be 35. This must be 35. So I'm gonna just write 35. Once again, I'm gonna find this dot. I put the dot here, and then I align every line, and I follow this red line and at 35, because this guy is between 40 to 30. So this is 35, and degree is over there, but if you don't like it, you put another degree over here. Okay, and still you can write plus minus 2. If you are not sure, then plus minus 2 will save you. And then we're gonna go to the next one, 70 and 71. So 70 and 71 is a toy to me. A toy is inside the bag, and let's see what information is given. I see that there is a displacement, so displacement is 0.070 meter, and I also see the Newton. F is equal to 12 Newton. Now what we need to find, calculate the spring constant. The spring constant is Hooke's law to me. So Hooke's law is F equal to kx. So k is equal to f over x. So f is 12 Newton and x is 0.070. So 2 meter. So 12 divided by 0.070 is 1.71 to me. So so k is 1.71. So k is 171 Newton meter. Very good. That's that. So now 72. Calculate the elastic potential. So we have to find the potential of the spring constant. Potential of the spring constant is just the. So you're gonna write half kx squared. So half k, we just found k 171, and x is 0.070 squared. So if you do the math, you're gonna get like what? So 171 divided by 2, that gives you 85.5. And if you do 0.070 times 0.070, you get 0.0049 times 85.5, that gives you 0.42 what? 0.42 joule. Nice and simple. You're done. Identify one form of energy to whose electric potential energy is converted. So elastic potential energy of a spring converted to kinetic energy, for example. That's it. And then we're gonna go to the next one. We're almost done with 2016 reasons. Nice and simple. It asks us to do, it's something like electricity, is electric circuit look like, because I see volt. When I see volt, it looks like electric circuit to me. So volt is 12 volt voltage, and current is 0.6 amps. It contains a lamp. Okay, using a circuit symbol, draw a diagram. Okay, so draw a diagram, and that has to be parallel with this thing over there. So I'm gonna draw a circuit. So draw a circuit, draw an electric circuit. So with 12 voltage. So I'm gonna draw 12 voltage. So this is a battery, and this is plus, this is minus, this is 12 voltage, and this is okay. So this that's how it look like. So this is a lamp, and this is a resistor. Okay, this is a lamp, this is a resistor, and that's done. We are done with 75. Calculate the current. So the total current is equal to 0.6 amps. Now we understand that this is parallel. So voltage is same. So voltage across. So the equivalent voltage is voltage 1 is equal to voltage 2. However, the current would be equivalent current would be current 1 plus current 2. and the resistance would be resistance 1 over R is equal to 1 over R1 plus 1 over R2 by Ohm's law. So we will probably have to use them, but we don't know. Calculate the current through the lamp. So current, how much current here? So we have to use something called, I don't know, current. So current is in the lamp is equal to once again VIR. So that's Ohm's law triangle. So current is V over R. So V over R. So now, do we know resistance? What other information is given? 12 voltage, this ampere. Oh, what? The lamp is operating at 6 watt. So the power is given. So power is 6 watt. So we have to use something from there. So power, go to electricity, look at power. The power is equal to V square R. So that's easy and simple to me. Power is equal to oh no, we are trying to find the what? Calculate the current. We are trying to find the current. So then P is equal to VI. So P is equal to VI. So I is equal to P over V. So P is equal to 6 watt, and I is equal to the same. Current is same across the series circuit. So we'll be able to use this I. Where is that I? Here is some current in the circuit. I wrote it 0.60 amps. So 6 divided by 0.60, 6 divided by 0.6 is what? 6. Oh, voltage. This is voltage 12. So 12 voltage. So 6 divided by 12, that gives us 0.5. So 0.5 amps. So 0.5 amps. So once again, there is a current over here in the lamp is 0.5 amps. Now next problem, determine the current in the resistor. So there are total resistor current in the resistor, and that is 78. So you're gonna go 78. 76 and 77. This is just 0.5 because P is equal to VI once again, and I is equal to V over V, and P is equal to 6 watt, and V is equal to 12 voltage, and that's 0.5 amps. So there is 0.5 amps in this. So then what is how much current is in the resistor? So current in the resistor is what? So we know that total current is equal to current in the lamp plus current in the resistor. So then current in the resistor is total current minus current in the lamp. So current in the resistor is total current is 0.60 amps minus current in the lamp. Lamp is 0.50 amps. So current in the resistor is 0.10 amps. So 0.10 amps. Current in the resistor is 0.10 amps. Great, nice and simple. Now we have to calculate the resistance in the resistor, and that would be 79. So we are doing the 79. We are calculating the resistance in the resistor. So the resistance in the resistor is V over I. V is 12, and I is the current in the resistor is 0.10 amps. So that gives you 120 ohms. But make sure you say ohms, and that takes us the last problem. And last problem is always the easy one. Where is the last problem? This is the last problem. Last problem is the great nebula blah 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 and blah 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 blah, and then N3 to N2. Long time ago I told you this is N1, this is N1, this is energy 1, and energy 1 right here. Look at the second page. You're gonna see energy 1 is negative 13.60. So negative 13.60, you're gonna write it. This is 1, and we are interested from N3 to N2. So this is E2, and this is E3, this is N2, this is N3, and E2 is negative 3.0, and E3 is negative 1.51. Now the jump from electron was here, it jumped right here. We have to find the electron volt. Very easy and simple, very easy and simple, and that is our 81. So from, say, determine energy electron volt when N3, so N3 minus N1. N3 is how much? N3 is negative 1.51, negative 1.51, and N1 is how much? N1 is negative 3.40, so negative 1.51 plus 3.40. If you do the math, you have a calculator, so 3.40 minus 1.51, that gives you 1.89 electron volt. Make sure you write electron volt. Electron volt and joule, they are same, but you have to write electron volt. Now that takes us to the next one. Determine the energy in joule. Now you have to convert that electron volt in joule. Easy and simple. 1.89 electron volt times one electron volt. One electron volt is 1.66 times 10 raised to negative 19 joule. Electron volt cancel. Now if you do this guy, 1.89 times 1.6, that gives you 3. That gives you 3.024 times 10 raised to negative 19 joule. That's how you convert electron volt to joule. Make sure you never forget that. Now that takes us to something very easy, and determine the energy. Okay, calculate the frequency. Now calculate the frequency of emitted photon. So E equal to not mc squared. E equal to go to the way modern physics. If you go to modern physics, modern until you find the modern, you found the modern. So E equal to HF. So E equal to HF, and H is the Planck constant. Look for Planck constant, the smallest one. This guy is the Planck constant. You try to find F. F is E over H. E is 3.024 times 10 raised to negative 19 joule over the Planck constant, 6.63 times 10 raised to negative 34 joule times second. And then if you do all the math, you get 4.56 times 10 raised to 14 hertz. That's it. Now that takes us to the next one. Identify the color. What is the color of this light? That's what you're gonna write. 85. The color of this light is easy and simple. Now you're gonna go to this is within the visible spectrum, because 4.56 times 10 raised to 4, 10 raised to 14, 10 raised to 5. So everything is in the visible spectrum. Now so you can either write visible spectrum, whatever is spectrum, but to be more specific, you look for 4.56. So it is 4.56. So if you look for 4.56, 4.56, so this is between 4.56 is here, 4.56. 4.56 is between 4.82 and 3.84. So that must be that. So this is right. However, in the test, I want you to write visible spectrum. That is like you are not taking any chance. Why should you take chance? You wanna, if you are like me, like find it and between that, I hope we have time. Then you do that, read. Otherwise, you just write visible spectrum. Okay, guys, good luck. We've ended 2016. Now we are moving to 2015. Ready? Let's go.